Is that on?
Yeah, that should be.
Is this thing on?
Oh.
Hello? All right. Let's get started. A little bit about myself. My name is obviously Michael Minella. I work for SpringSource, which is part of Pivotal. It's a new spinoff of VMware and EMC. As the project lead for Spring Batch. I started that in September, taking over for the project founder. I'm also a member of the JSR 352 expert group. So that is the Java Batch JSR, so bringing essentially the Spring Batch functionality into Java. I'm also the author for Pro Spring Batch. Really, all that means is I've done a lot of Spring Batch stuff. Here's my contact information. Don't worry about writing any of it down. That's all you need to worry about. That's my GitHub repo. This presentation and all the sample code, including directions on how to run it, are all available already on the GitHub repo. The one rule, if I will, that I have for my talks is ask questions when you have them. Me standing up here talking at you guys for an hour can get kind of boring, so if we get a conversation going, it's definitely more beneficial for everybody. Tonight I'm going to talk about three things. I'm going to talk about Spring Batch from an overview perspective, kind of just set a baseline for what the framework does, what it doesn't do, so we're all on the same page. Then I'm going to talk about the cloud a bit, and then we're going to look a little bit into the future. Yep. Yes, there is. It's the one I wrote, Pro Spring Batch. Great Christmas, Father's Day, etc. Mother's Day. Thank you. So then we're going to look into the future. So what are the next few releases of Spring Batch going to bring? Let's get started with an overview, though, of Spring Batch, the framework. Can I get a quick show of hands? Who here has used Spring Batch before in some capacity? A couple here, a couple. Wow, actually, not too many. There are quite a few. Has anybody used Spring Batch for something other than the stereotypical nightly transactional job? Got a hand over here? What you using it for?
We use it for like this queuing system that we have. We sort of like run big files.
Okay.
After the queuing and then write it out to like this kind of repository.
Okay.
And then run it back through.
So kind of a micro batch scenario where you're getting stuff, you're running. It's a batch process, but you're running it real time.
Yeah.
Cool. Any other like I said, nightly traditional batch processing? Okay. You guys are doing the migrations that are.
Yeah.
Okay. So on demand. Cool. Before we get into the framework, though, it's a good idea to get kind of a baseline definition of what batch processing is, so we can understand the problem Spring Batch is trying to solve. Who wants to venture an idea on what batch processing is? Yeah.
Why not? So you got a bunch of steps. You want to do them. You want to start them at some time. They run. They don't need a person to watch them. Just kick off the next one, and then maybe you get fancy. Maybe you have a little flow control or if-else stuff. But mostly, you start it up, it runs, and it doesn't need a person to click away to a keyboard for it to do its job.
Okay. So I heard steps, so decoupled processing. I heard a process that doesn't need interruption, no human interaction. That actually, it's almost as if you just read this next slide. My definition of batch processing is processing without interruption or interaction. When we think about a lot of the programming we do, a lot of the programming out there right now is web programming, right? When we think about how that works, you've got a big computer that somebody goes to their laptop, opens up a browser, sends a little bitty request to that big computer. That big computer does a little bit of processing and sends it back to the browser. The only reason we have that big computer back there in the first place is because we hope that happens a lot of times. If it doesn't happen a lot of times, we got a big computer just sitting there. Batch processing goes back to the first days of processing. If we think of ENAC and the original computers as big as this room and more expensive than anybody's car in this room, it required a lot to justify the cost of those computers. You had to keep them busy. So to do that, you had to get your data all set up and then just keep chugging it through that computer. Keep that computer busy. That's what batch processing is intended to do. It's intended to take a batch of data and process it all at once without interruption or interaction. Does that make sense? Some typical use cases. Generation of statements. Everybody here gets cell phone, electric bill, all those types of statements. Maybe whether they come through the mail or via spam in your inbox email. Those are all typically batch processes. ETL processing, so moving data around from one data store to another. Statistical and scientific analysis. If you think of things like the Genome Project or weather forecasting, those gather large amounts of data and process them all at once with some type of outcome. Big data and data intelligence, so Hadoop or other NoSQL options, those are all really batch processing. MapReduce is just batch jobs. Vulnerability scanners? Probably something that wasn't on your list, but we'll get to that in a little bit. I'm going to throw out some terms tonight, and I want to make sure that I'm not speaking Chinese to everybody, so let's get kind of a baseline from a terminology perspective. A job. So a job is essentially a process that's going to run from start to finish without interruption. It's the entire process. So if we think of the nightly statement process, that's the job. That job is broken up into steps. If we think about the statement job, it might have an import file step. It might have a apply transaction step and then a generate print file step. Each one of those steps are independent, and they together make up the job. Within each step, the individual piece of data we're going to be processing over and over and over, that's the item. So if we think of that statement job, each one of the customer transactions, that would be the item. If we have 1 million of those items to process, we don't want to process those in a single transaction, right? So we divide those up into chunks. So if we've got that 1 million record file that we're processing, we might want to break those up into 1,000 record chunks where we commit after each chunk. If we think of Spring Batch from a visual perspective, this is essentially a diagram of a 3-step Spring Batch job. The way this works is step 1 would start, execute, and finish. Then step 2 would start, execute, and finish. Then step 3 would start, execute, and finish. Within each one of those steps, there's optionally 3 components. There's an item reader, which is responsible for the input of the job. There's an item processor, which is going to do whatever manipulation to that input is required. And there's an item writer that is responsible for the output of the job. I said that they're optional. The optional component here is the item processor. You can go reader to writer. There is another type of step that we'll look at tonight. It's called a tasklet step. The idea there is if you aren't processing records over and over and over, a tasklet allows you essentially to run whatever generic code you need to run. It might be call a single web service and be done. It might be initialize some code, whatever it is, but it's not the item-based processing that this model shows. Does that make sense? Within a step, the way these 3 components interact, you've got the item reader, the item processor, and the item writer. For each chunk, so within each transaction, for each item that we process, the item reader is going to read it in and pass that to the item processor. The item processor is going to process the item and then hold on to it. Once all of the records within the chunk have been read and processed, that chunk will be passed on to the item writer for writing. It's a little bit of an optimization so that instead of writing every individual record, you only write at the chunk boundaries. So if I'm processing 1 million records and my chunk size is 100,000, I'm only going to write 10 times. Obviously, when we're processing a large amount of data, we want to be able to recover when things go wrong. In order to do that, we need to maintain the state of the job. And we do that in the job repository. The job launcher is the piece of code that is responsible for kicking off a job. When he reports to the job repository, he says, I've started job X. The job, as it's processing, is going to report to the job repository and say, I'm working on step Y. Within each step, as it's working through its load, it's going to say, I've completed chunk X, chunk Y, chunk Z. The whole time that batch job is processing, the job repository is maintaining that state, so if something goes wrong, Spring Batch can restart essentially where it left off. Spring Batch, out of the box, provides 2 job repository implementations. One is a map-based one, so in memory. The other one is JDBC-based, so database. We provide the schemas out of the box for just about all the major databases available. Features of Spring Batch. Transaction management. So the chunking, that transaction boundaries and the rollback and all that stuff, all that's handled by the framework. You don't have to worry about any of that. Chunk-based processing, so that optimization of reading, processing, and then writing at the end of a chunk, that's taken care of. Declarative I/O. So if you want to read from a file, whether it be a flat file, whether it be CSV, XML, you want to read from a database, JMSQ, you want to write to a database, you want to write to a queue, you want to write emails, you want to write flat files, XML, all of those and many more. You want to write to Neo4j, MongoDB, all of those. You don't need to write any code to do. We provide all that out of the box. Start, restart, and skip capabilities. Obviously, these jobs, as we discovered, typically run overnight. When things go wrong, that means somebody's getting a phone call, and we don't want that at 2 in the morning. At least I don't. So we built features into the framework to be able to minimize those impacts. So start, restart. So a job goes down, we provide the ability to restart it where it left off. Skip capabilities. If I have an item that's bad, and I just want to skip it and I'll take care of it in the morning, we provide the facilities for that. So you can just write it to a file and look at it when you get in the next day. We provide a web administration interface. My opinion, the coolest thing about the administration interface, which we'll actually look at later, is that it also exposes most of the job repository and job operator functions via RESTful web services. So all you need to do is drop in a couple jar files in your application, and now you have the ability to start, stop, check state, all those features of Spring Batch within your application via RESTful web services. My opinion, the best feature of all, it's based on the Spring framework. So all the things you know and love about Spring, the transactions, the AOP, the bean configs, the annotations, all that stuff, it already just works. And in my opinion, Spring Batch is one of the easiest ramp-ups of any Spring Batch, or of any Spring framework. If you understand Spring, the ramp-up from Spring to Spring Batch is actually, in my opinion, one of the easiest ones. Spring Batch is in production in a number of companies. The ones I can mention publicly: Chicago Board Options Exchange, Morgan Stanley, HSBC, Federal Reserve, Orbitz, Walgreens, Major League Baseball, and the National Hockey League. Does anybody have any questions about the framework? I know I went through that kind of quick, but we're here for a cloud talk, so.
Is there, maybe this isn't considered a feature, but anything to manage multi-core threading? I was going to repeat the question.
Okay. So is there anything within the framework to handle multi-threaded processing?
Yes.
Yes. We are going to be getting to that in next. So, any other questions about the framework? One thing I want to call out about it that I didn't mention earlier on the features list is a feature that is notably not there, which is scheduling. I know when we were talking about the definition of batch processing, the word scheduling or time-based processing is one of the things that almost everybody mentions every time I give this talk. Spring Batch does not do scheduling by design. The reason we do that is because we've got probably 2 or 3 dozen companies represented here, right? I bet if we took a poll and asked how many, what your scheduler of choice is for each company here, I'd easily get 10 to 20 different options. We don't want to tie you to a scheduler, so our goal is to make that integration as painless as possible. Any other questions about the framework before I move on? Let's talk about the cloud. When we think about scaling Spring Batch, there's 4 different options. Option 1 is the multi-threaded step. This is really the easiest way. Essentially what happens is each chunk gets put into its own thread. It uses the Spring task executor abstraction, so thread pool bound, all that stuff that you know and love. But like I said, it's really just basically a flag. Option 2 is parallel steps. So you have 2 independent steps that have no dependencies between each other. Let's say you've got 2 files you need to import with no foreign key relationships in a database. There's no reason those imports can't run in parallel, right? So this allows you to run those steps in parallel. One important note about these 2 particular scalability options: single JVM only. To get into remote JVM, we start off with remote chunking. Remote chunking, the idea is it's a master and slave configuration, with step 2 being the master and step 2, A, B, and C being the slaves. Step 2 is going to read in the data and send it over the wire to the slaves. The slaves are going to do the processing and then send the results back over the wire to the master. It's important to note here that the data needs to be local to step 2. So if it's a flat file, step 2 is the one that needs to be able to see it, not the slaves. You need guaranteed delivery between the two because you're actually sending the data across. We don't want to lose any of your data. And if you're sending all of your data over the wire, I'm sure you can figure out pretty quickly, if you have a lot of data, this is very inefficient from an I/O perspective. You really only want to use this if processing is your bottleneck, not I/O. The alternative is remote partitioning. Here, instead of sending the actual data across the wire, we send a description of the data to be processed. Imagine you've got a database table with 1 million rows in it. Instead of sending all 1 million rows over the wire, I'm just going to send process records 1 through 1,000, 1,001 to 2,000. Just those key values I'm going to send over the wire. And then each one of the slaves is responsible for reading in its own data, processing it, and writing it out locally to itself. Key points to note about here. Now the slaves are responsible for the I/O, so they need to be able to see the data source. So if it's a flat file, it doesn't matter where the master is at. It matters where the slaves are at. Guaranteed delivery isn't required because you're just sending descriptions across. We can regenerate those. But these guys need access to that job repository, the slaves. Whereas remote chunking, they do not. Does that make sense? Let's talk about the sample app that we're going to develop tonight. I mentioned earlier vulnerability scanners. In a previous life, I worked for a security company called TrustWave on the vulnerability scanning team. We didn't do it this way, but I thought it was a cool use case. We're actually going to write a simple Vuln Scanner tonight. Has anybody used a vulnerability scanner before? Nessus or any of the variety? Nessus or something different? Okay. Anybody use anything else? Okay. Nessus actually is the most common one. It used to be open source. They've since taken it closed source. But the way vulnerability scanners work is really, really, really simple. This is an example of a test that the open source version of Nessus would run. It's written in NASL, which is the Nessus attack scripting language. You don't need to know anything about NASL to figure out what this does. For each item, we're going to grep for a particular pattern. If that pattern's found, we're going to run a regular expression. If that regex matches, it's considered vulnerable. All Nessus does is it connects to a port and reads the banner information. So if I telnet into a port and it gives me that, welcome to such and such a server, this is version 5.3 of telnet, blah, blah, blah. All Vuln scanners do is save off that banner information and run regexes against it. If that regex matches, you're considered vulnerable. Pretty simple when you think about it. This is the vulnerability scanner we're going to write tonight. It's a 3-step spring batch job. It takes in 2 parameters, the first one being the IP we're going to scan, the second one being the location of the report we're going to generate. Step 1 is one of those tasklet steps. It's going to take that IP address and insert into a database 1 record for each port we're going to scan. In the PCI world, in order to be considered compliant, you have to run a full port scan, which means you have to scan 65,535 ports per IP. If you're scanning a corporate network, I'm sure you can do the math. This becomes a very big data problem very fast. So tonight we're just going to scan a single IP, but we're going to generate all 65,535 rows. Step 2 is a partition step. There we're going to pass out descriptions of that data to the slaves, and the slaves are going to do the actual network scanning. Step 3 is going to generate an XML-based report telling us which ports were open and what banner information we received. We aren't going to actually run the NASL scripts, but we're going to have all the information we would need if we wanted to run those. I haven't had time to get NASL running on the JVM. In order to understand a remote partitioning, there are two components you need to understand: the partitioner and the partition handler. The partitioner is the piece that needs to understand your data. It's the piece that's going to look at your data. Let's say it's a database table, and it's going to say, okay, I've got X number of records. Divide that by however many nodes I've got, and that's how I divide up the work. It may also be, let's say it's a file. It would be responsible for parsing up the file into smaller files to be worked on. So think partitioner, data. The partition handler is the piece that's responsible for understanding how to distribute that information. By default, Spring Batch provides two partition handlers: a task executing partition handler, so thread pool, or the one we're going to be using tonight, which is a message channel partition handler. So we're actually going to be using Spring integration message channels as the communication. In this case, it'll be backed by Rabbit. If we get into the actual communication piece, the pieces at work for the actual communication side of this, you've got the master on the top and the slave on the bottom. If we start with the partition handler working across the top going to the right, so you have the partition handler is going to pass off the partition information via the request channel out to a gateway that's going to send it off to RabbitMQ. On the slave side, going from left to right, I'm sorry, from right to left, the gateway is going to pick up the request, drop it on a request channel, which is being listened to by a service activator. These are all Spring integration components that are available out of the box. The service activator is going to pass on the request to a component that understands how to execute a Spring Batch step outside of the context of a Spring Batch job. So in this case, these remote steps aren't going to execute in the context of a job. They're just going to execute on their own. So picture them essentially as mini jobs. Once those complete, they'll respond to the service activator, go out via the staging channel at the bottom to the gateway that they came in on. That's on the slave, out to RabbitMQ, and then the gateway at the top will pick up the response and drop it on the staging channel at the top, where it'll be held off by an aggregator. The partition handler expects a single response, yet if we send out 10 partitions, that would be kind of confusing. So we use an aggregator to hold those responses until all 10 have been responded. Then the aggregator lets them go to the partition handler, indicating that the processing is done. Does that make sense? I know what you guys are thinking. This guy's nuts. He's come up with this complicated example. It's going to take all night to explain the code. You need all these classes and all this configuration. This demonstration takes 5 Java classes and technically 1 XML file. The 5 classes are the load targets tasklet, the partitioner itself, which technically we give you. I've just modified it very slightly. The item processor and the slaves, that's the piece that's actually doing the scanning. That's 3. I need a domain object. That's 4. And I use a row mapper, a plain Spring JDBC row mapper in the generation of the report at the end. That's 5. Before we get to the actual code, though, let's talk a little bit about where we're going to deploy this. I mentioned this is a cloud talk, so let's talk clouds. There's a number of different options, right? Amazon, Google App Engine, Cloud Foundry. Yes, you can even run Java on Windows Azure. But what it really comes down to is infrastructure as a service versus platform as a service. When we think of infrastructure as a service, this is Amazon EC2. This is anytime you're thinking virtual machines. When I think about deploying a Java application on Amazon EC2, I get nightmares. How do I do that? I have to set up a virtual machine, right? Well, I could go out to the AMI library and download one that's already available. That's if I really don't care about security, all right? Passwords are set. Public and private keys, everybody knows. There's no way I'm actually running code I care about on a publicly distributed AMI. So that means I need to build it myself, right? So that means I need to install an operating system and harden it. I to install Java. If I'm running on an app server, I need to install that. Oh, I want a database. I need to install that. God forbid I know what actually is going on my servers, so that means I need to install some sort of monitoring. I finally get to install my application, and I need to do this for each box? This is better than what we currently have? This is nuts. Platform as a service is really the direction that the cloud is going, really across the industry. In a platform as a service, I provide a name. I give some indication of how big of an instance I want, in this case RAM. I say the number of instances and request whatever services my application needs. I know I need a database. I know I need MySQL. I don't care where it lives. I don't care how many instances it is. I don't care about the username and password. That's not my problem. I'm a Java developer. I know I need messaging. I don't care where Rabbit is. I don't care about any of the connection stuff with that. Tonight we're going to be using Cloud Foundry. Cloud Foundry is an open source platform as a service. It supports along the left, it supports all the frameworks you know and love, so Java and Spring, Scala and Play, Ruby, Rails, you can do Node, all the stuff you know and love as far as that goes. Along the right, it provides a number of services, MySQL, Mongo, Redis, Rabbit, Postgres. There are other ones available. I don't know how they cost or whatever. These are all free. We'll be using MySQL and Rabbit tonight. And then across the top, you can run Cloud Foundry on the public cloud. We're actually moving our current infrastructure to use Cloud Foundry on Amazon. You can run it in your own data centers privately. Or actually tonight I'm going to be demoing it using the micro cloud, which is actually a VM installed on my laptop. So I have the exact same stack set up that I could deploy it to the cloud running here locally on my laptop. Does that make sense to everybody? Who's tired of seeing PowerPoint and wants to actually see some code? All right. Oops. I'll start off with the 5 Java classes. In the back, can everybody see that all right? Cool. So we need a domain object. This is the target object. What's it consist of? It consists of an ID for a database ID, a string for an IP. Don't do this in real life. An int for a port, a Boolean for connected, and a string for the banner data that's returned when we connect. You'll notice I'm using big B Boolean here. There's a reason for that. The way I've got my queries set up, if something fails and the message gets put back on the queue, I'll be able to tell which records were processed because the connected will still be null instead of true or false. So when the next guy picks up that message, he'll be able to start back up working without having to rescan the ports that were previously worked on. You can do this with a flag as well. I'm cheating with the data to be able to do that, but that's a common paradigm. The rest of this is just getters and setters. Let's look at the row mapper. If you're familiar with Spring JDBC, this should be pretty straightforward. I'm just implementing the row mapper interface, map row, taking the result set and putting it into an object. Like I said, if you're familiar with Spring, it's pretty straightforward. I'll go in order in the job, so we'll look at the load ports next. So this implements the tasklet interface, which consists of a single method execute. This is, like I said, this is that non-item based processing. I could have written a writer and had it generate these items if I wanted, but this just seemed a little cleaner for me. So what does this do? It finds out what the current max ID is in the table, just so I can start. And then I'm just going to loop through the number of ports. In this case, it is the 65,535. Creating a record for each one and inserting it. That's it. When I'm done, I tell Spring Batch that this tasklet is complete. Stop me if I'm going too fast, please. The column range partitioner. This is the class that I mentioned that you actually can steal from Spring Batch. We give it to you in an example anyways. So the partitioner is responsible for knowing about the data piece of partitioning. So in this case, this particular partitioner knows how to look at a database table, a column within a database table, and divide up the work that way. So when we get down to the actual partition method, I'm going to get the min ID, the max ID, and the number of records. And then I'm just going to divide them up that way. So query for int min, query for int max, the number. And then for each partition, I'm going to create an execution context. An execution context is essentially the session for batch processing. So if you think of a session in web programming, it's a place where per user you can put key value pairs, right? The execution context is essentially the same thing for a step. So for a step, I can put in key value pairs that other components within the step can access. In this case, for partitioning, we use that as the storage location of the information that I'm going to send to those slaves. So remember how I mentioned that each one of those slaves is going to get a description of the data? The execution context is where I put that description. In this case, I'm just going to put the min value and the max value of the IDs that I'm supposed to process in between. Does that make sense? The last piece of code is the actual item processor in the slave. This is the piece that's actually going to do the port scanning. In real life, I would never actually do it this way because it's about as loud as you can get from a intrusion detection system perspective, but it works for this. So the process method on the item processor takes my domain object. For each one of those, I'm going to use plain Java sockets, and I'm going to connect to the IP and port. If I connect, in other words, if it doesn't throw an exception, I'm going to assume it's connected, and then start reading from that socket. Anything I get back is that buffer information we talked about, and I'll store that on the target. Any exceptions, I just close everything out. Any questions on the Java stuff before we get to the XML? The XML I'm going to cheat on slightly from a presentation perspective. When you pull it down from GitHub, you'll see this is actually all in one file. But in order to describe it, it's easier if I break it up into two. The first one I'll talk about is the one with all the batch stuff. The second one has all the Spring integration stuff. So this is the batch file that I was talking about. As you can see, we've got a 3-step job. So step 1 is load ports. Once that step is done, it'll move on to the master scan ports. Once that one is done, we'll generate our report. That's the 3 steps within the job. You'll notice that we also have the scan ports, which is outside of the scope of a job. That's the piece that the slaves are going to execute remotely. From an XML perspective, let me switch over to so you guys can read it. This is how you configure a job with XML in Spring Batch. So you've got a job tag with an ID that configures the job itself. And then within there, we'll have 3 steps. Step 1, step 2, and step 3. So load ports. Once that's done, it goes to master scan ports. Master scan ports, once it's done, goes to generate results. And then generate results goes nowhere because that's the last step. For load ports, we've got the tasklet. That's just refers to a plain Spring Bean that is configured for the class that we looked at a minute ago. The second step, the partition step, we pass in 2 pieces. It's the partitioner and the partition handler. The partitioner is the piece that we already looked at in code. The partition handler I'll get to in a minute. The last piece, to generate results, is realistically the most normal Spring Batch step. Here we have a reader and a writer. In this case, the reader is a JDBC-based reader, and the writer is an XML-based writer. So here, I'm using Spring Batch readers and writers out of the box to do my input and my output. The other thing to note here is for the last one, my commit interval is 10. There's 22 open ports on the box we'll scan, so it'll commit 3 times. The rest of this stuff is really just spring beans. So we've got load ports tasklet. We've got the partitioner. The partition handler is the only real interesting piece here. Here we're using the message channel partition handler. This is one of the two partition handlers we provide out of the box. This one works with Spring integration message channels. This particular partition handler takes three things. It takes the name of the step we want the remote steps to execute, the grid size, which is a non-binding value, basically provides guidance to the partitioner on how many workers it's going to have. And then the messaging operations is just a messaging template, so that's the piece that's actually going to do the work of working with a message channel. For the record, I cranked up the timeouts everywhere because this is a demo. The item reader, I'm using a JDBC paging item reader, so this will look at a database and pull back records in a page style. In this case, this one is used to is part of generating my report. So this will read back the items that we actually connected with. Got the output file, the XML writer. So in this case, I'm using, like I said, an XML-based writer. It takes a reference to the file, some form of marshaller. In this case, I'll use Xstream. And I'm mapping the root tag of the document to open targets. The target marshaller itself, like I said, I'm using Xstream. You can use any marshaller you want. The only configuration I'm providing here is I'm aliasing the root for each item. So Spring Batch Domain target. The root tag for each item will be the target tag. Everything else will be generated based on the attributes of the class. Scan ports. This is the step that is outside of the scope of a job. This is the actual step that the remote slaves will be executing. Again, just a reader, processor, and writer. Nothing exceptional here. The reader is actually another JDBC paging item reader. The only thing interesting here is you'll notice in the where clause, I'm doing the ID between the min ID and the max ID that it gets from the step execution context. So as those partitions come out, this item reader will only read the ones, they're the records that were basically assigned to it. Processor and writer, these are just references to the processor is a reference to the class we already looked at, and the writer is a batch item writer. Questions on the XML for the batch side?
So in the partitioner where you pass in the grid size?
Yep.
So that assumes that, again, okay, you use three, so you've got like 3 worker nodes?
Yep.
Or, I guess
again, non-binding.
Okay, it's non-binding, but I guess is there ways to, dynamically scale that? So
Sure.
I want to add 50 or whatever.
Yep. So you can do two things. If you write your partition, handler, or actually the partitioner is the piece that really uses it. If you write your partitioner to actually care about that value, you can inject this dynamically, whether it be a properties file or you could have a factory method. You could as a job parameter, or you can, as you can see with what I'm doing, since it is non-binding, we're actually going to have a total of 12 workers working on the job tonight.
And all of this is deployed to everything? Is it just deployed to...
The way I've got it set, the actual file setup, which is vulnscanner.xml when you pull this down from GitHub, I actually have 2 Spring profiles. One's master and one's slave. So I'll deploy this as 2 separate Cloud Foundry applications, and then I'll set one to be the master and one to be the slave. Does that make sense?
Excuse me.
Yeah.
Several products now are starting to trend towards using annotations as opposed to XML for configuration. Is this product following the same pathway or no? Can you repeat the question, please?
Sure. So the question was annotations. Do we have to do all this in XML? Am I stuck with XML hell, basically, right? Kind of. So we aren't doing annotations, and there's a reason for that. On the expert group for the JSR, we explored annotation, configuring batch jobs via annotations. What we ended up finding was that configuring flow-based things like a batch job is really painful via annotations. You end up with blocks of annotations in order to get anything close to what we can describe in XML. We actually, when we decided to abandon that and go with XML in the JSR, we actually got pushback from the executive committee for the JCP for exactly asking where the annotations. So there are some things you can configure via annotations, like listeners and readers and writers, the actual methods instead of implementing interfaces. The other thing that I'll get to in a minute with future releases is we are enabling Java config. So while it's not annotation based, we're providing a number of factories and builders so you can do this in Java instead of XML.
Gotcha. So if something goes wrong, you get a definitive stack traces to your.
Oh yeah. Question over here?
Question. Just looking at some of the data operations, it looks like a lot of them are batch specific. Is there also a drive towards using more like Spring Data framework for those data operations? Or is there even interchange between those?
You guys are killing my future slides. So that's that. The future slides. So that's available. The Java config is available in the current release candidate of Spring Batch, which just came out last week, 2.2.0 RC1. Another feature of 2.2.0 RC1 is integration with Spring Data. Out of the box, we now have readers and writers for Neo4j, MongoDB. We've got a writer for Gemfire. I'm forgetting one other one. We didn't do Redis for a reason. If anybody is interested, it's just there's so many different use cases for Redis. If we have requests for the individual ones, we can, but we'd want to spend a ton of work writing readers and writers nobody's going to use. The other one that we did, though, is just a blank repository-based reader and writer. So if you have your own reader and writer, or your own Spring Data repository implementations, we can wrap that in a reader and writer to integrate with Spring Batch out of the box. Any other questions on the batch side of the config before I move on to the Spring? Yeah.
Just real quick, I'm assuming you can read and write to Hibernate?
Yes. Yep. But again, you're killing my future slides. We support it, but we upgraded the version as part of this. Now you can use Hibernate 4. So now let's look at the actual Spring integration side of this. Come on. So this diagram should look vaguely familiar. It's essentially the same thing I showed on my PowerPoint presentation. The only thing that's missing is the partition handler. Imagine that's off to the left. You start off with the partition handler puts something on the outbound request channel, which is going to be listened to by a gateway. That gateway is responsible for sending the message out to Rabbit. Once the responses come back, the gateway will pick it up, drop it on the inbound staging, which is being listened to by the aggregator, which once it gets all of the responses from all the partitions, the aggregator will send the results back to the partition handler.
Possibility for different policies for aggregator?
Yes.
So that ignore if 1 out of 7 does not arrive after so long, keep on going anyway.
So the default one, actually, you can do that with just the default. There's actually a value on the default aggregator, which is what is it? Release. When we get to the XML, it's like release partial results when timeout or something along those lines. It's in the XML. Configure that to true. Once it's a timeout, it'll send whatever it's got along. This is the master side. Was there another question? Okay. This is the master side. The slave side. So we've got a gateway listening to Rabbit. When it gets messages, it drops them on the inbound request, which is being listened to by the service activator. Service activator is going to call a component that knows how to run that scan step. Once each one of those steps completes, it'll pass it back via the outbound staging to the gateway, back out to Rabbit, out to the master. So here it is in XML. I'm going to go through this quick. Like I said, get it out of GitHub. It's a lot easier to go through on your own time. I don't want to kill everybody with XML hell. But really quick, so I've got the partition handler. This is just copied. Regular Spring integration channel, which hooks into an outbound gateway. The only interesting thing on the outbound gateway is the request and reply headers that we have mapped. Besides the standard ones, the correlation ID, the sequence number, the sequence size, those are used by the aggregator to tell when it's got all the results. So the correlation ID would be scan job and the step execution ID, and then the sequence number 1 of 10, and then the sequence size 10. So when it gets 1 of 10, 2 of 10, 3 of 10, once it gets all of those back, it'll know to release the results. The inbound staging, again, just another channel. The aggregator, again, this is just a standard Spring integration aggregator. This is that send partial result on expiry equals true. We have a Rabbit template, which does the actual talking to Rabbit back and forth. This is one of the interesting things. So I mentioned before with the platform as a service, I don't care where Rabbit lives. I don't want to have to configure the ports and URLs and all that type of stuff. This is how you do it in Cloud Foundry. Just this. Cloud Foundry, Rabbit connection, and ID. That's it. I don't need to know about the usernames or passwords or any of that stuff. I don't care. Cloud Foundry will give it to me, and I don't have to worry about it. Everything we've covered in this XML above is essentially the master. On the slave side, I've got the configuration of the actual queues. I have the inbound gateway. So this is the piece that's listening to the Rabbit queues. That's going to drop it on the inbound request channel, which is being listened to by the service activator. This is going to call the piece of code that actually executes the remote step. Once that's done, the response gets put on the outbound staging, which goes then out via the outbound gateway. The only other piece of interesting code here is this step execution request handler. This is that piece of code I've talked about that knows how to execute a Spring Batch step outside of the scope of a Spring Batch job. Again, this is a piece of code that's provided with the Spring Batch framework. You don't have to write it. It knows how to get or take a step execution request and execute a job from it. Any questions on any of the integration XML? I know I went through it quick, but like I said, I don't want to put everybody to sleep.
What about you put some 20 or 30 step conundrum together and you don't end up at the end with exactly what you wanted? How does debugging work when you're putting these things together? And I guess a related question to that is what kind of automated test support?
So it was two questions. Number one, it was basically how do you debug this big thing, if I'm summarizing correctly, and two, automated testing support. I'll answer the second one first, which is automated testing support. We have there's actually a Spring Batch test project with a number of utilities that make testing jobs a lot easier. Plus, if you just look at any of our test cases, you can pick up pretty quickly how to test jobs easily. As far as debugging this goes, it's two things. Number one, we do a good job of managing that state through the job repository. So when, let's say, I have a remote step that fails, that remote step is going to report to the job repository its state, including the failure. So when a step fails in Spring Batch, we record the exception that it failed. We flag it as a failed status, and we store that stack trace in the repository. So all that's available for you. And then when you restart, once you fix the problem, when you restart, we're able to pick up right where you left off.
What if it doesn't process correctly, doesn't accept, but it's not correct on the other end?
Give me an example.
Say you've got a bunch of input transactions and you're doing a variety of things too, and on the other end, you end up missing some, or you don't get in your statement output or whatever, you don't see something in some of your test cases that you expected to see.
So like cross-checking type things?
Right. So it doesn't necessarily. I'm talking about errors that don't necessarily accept.
Mm-hmm.
Right. But you've got this big thing. How do you tell where you lost some of your transactions or what have you?
So 2 points on that. Number one, because of all the transactionality here, the idea is we don't lose the data in the first place. If it's purely a data issue, there are ways to handle that. Specifically, the scenario you're describing, I'd probably do those cross checks with a step listener, so that before Spring Batch says this step is done, do those cross checks, and then we give you basically one last shot to say that the step failed. That way, instead of doing that in a separate step, where that would impact restartability, because this step it completed, so we don't let you restart that typically, at least by default. So we would. That's the way I would recommend handling a scenario like that. Does that make sense? Other questions? Let's run this sucker. So to interact with Cloud Foundry, there's a number of different ways. Cloud Foundry is essentially, the API is exposed via a number of RESTful web services. A number of different clients have been developed around those. There's a Ruby one, there's a Java one. The Java one has been wrapped in a Maven plugin if you're interested. In fact, the way this project is configured in GitHub, the POM file has the majority of the configurations for Cloud Foundry already set up as well. So except for one small thing, which I just haven't updated recently, you can do everything via Maven out of the box. But what I'm going to use is actually the command line tool called VMC. The reason I'm going to do that is it kind of walks through the steps. This actually uses the Ruby client. I start clean, so I'm actually even going to do a Maven build. So I can really say nothing up my sleeve. Build success. All right. So to start off talking to Cloud Foundry, I need to tell it which cloud I want to talk to. I could talk to a public cloud. I could talk to within my data center. There's a number of different options, right? So in this case, I'm going to talk to the micro one that's running on my local laptop. So I'm going to say VMC target. I've already done this, so it should say the appropriate one. So this one's api.mminella me.cloudfoundry.me. To actually set the target, it's just VMC target, and then you pass in the URL. If I hadn't already done this, the next step would be VMC login, where it'll ask me for my username and password. I'll spare you guys that. To see the apps I'm running, it's VMC apps. It'll give me a list of the apps. As you can see right now, I'm starting clean, no applications. To see the services I've provisioned, again, I'm starting clean, no services. Really nothing up my sleeve. To deploy an app on Cloud Foundry, you do a VMC push. So what this is going to do, this is going to ask me a number of questions about my application and upload the application. By default, a push will also start my application. I don't want to do that in this case. Like I've mentioned, the way this is actually configured, I have two Spring profiles, a master and a slave. I'm going to use environment variables to specify which profile to activate. So I need to set that variable before I start my application. So I'm going to first do a push and tell it not to start my application. Then I'll set the environment variable. Then I'll start the application. So I'm going to do a VMC push, no start. So I need to give it a name. Can everybody read this, by the way, or do I need to increase it? Everybody's fine? OK. So I'll name it part. I want one instance. It auto-detects that it is a Spring application. I'm going to run on Java 1.6. 512 megs for RAM is fine. Remember that domain? That's the domain we'll be looking at the UI via the browser. Create service for this application. Yes, there's two services I need. I need a MySQL instance, and I need Rabbit. So yes, I'll do MySQL first. I don't care about the name. Create another service. Yes, this time I'll do Rabbit. Cool. Create another service. No. Bind other services, no. Save configuration, no. So my app has been deployed. So now let's update the environment variables. Let me see if I've got that handy. It's a lot easier than typing it. Come on. Slave. Master. So we use the VMC set-env command. So VMC set-env. Part is the name of my application. And I'm going to set the Java ops for my application. I'm setting two specific Java options. Spring.profiles.active. So this is how I tell a Spring application which profile it should be active. In this case, it's the master profile. And then I'm also specifying an environment variable. The web interface that we provide with Spring Batch supports a number of different databases. This is our way of telling it which one to use. In this case, it's MySQL. So I'll go ahead and update those. Start the app. And it's running. I need Safari. So this is the home page of the administration interface that we provide. Like I said, it's a pretty basic UI. One of the big benefits I see in it is the ability to access all this stuff via RESTful web services, of which all of the endpoints that we support are listed on this home page. So you want to get a list of the jobs, it's /jobs. /jobs/executions are the executions. You can get it via HTML or JSON. Again, all this is out of the box. You don't need to do anything. If I go to the Jobs tab, there's one job I can run. This is my Vuln Scanner job. Here I need to pass in the parameters. I'm going to pass in two parameters, an IP address to scan and the location of my report for the results. So let me get that real quick. Recent. So IP address equals the IP address, comma, output file equals the location of the output file. So if I launch it, it's started. So if we look at the actual execution, it's running. You can see the parameters I've passed in, start date, the start time, how long it's been running. There are two statuses within Spring Batch. The batch status is the thing that the framework works off of. The execution status is something you can manipulate. You can map the two, but we don't let you introduce new batch statuses because we need to understand that. So step one completed, and now we have the partitions running. So now you can see I have three of the slaves running. I have the master profile also running as a slave. There's no reason for my master to be sitting there idle while the slave instances are doing the work. So I've got him doing 3 partitions at a time as well. So you can see this guy's cruising through. But as I'm sure you guys can imagine, processing 65,535 ports at this pace, we're going to be here all night. Let's scale it up. To do that, we're going to redeploy the application, this time using the slave profile. So to do that, we're just going to do a VMC push again. Give it a different name. Number of instances again. Again, it detects that it's a Spring app, Java, same memory. I don't care about the domain because we're never actually going to hit it. Create services for this application. This time, no. I'm going to bind to the same services I've already provisioned. Bind other services, yes. So I've provisioned 2 services. I've provisioned MySQL and Rabbit, so I'm going to bind to each one of these. Which service? MySQL first. Bind another service, yes. This time Rabbit. Oops, 1. Save configuration, no. This time I'll set the slave profile to be active on the Part SL application. And then go ahead and start it up. Cool. You can already see, actually, no, hold on. I don't want to cheat here. 1, 2, 3, 4, 5, 6, 7, 8. There's 2 completed plus 2 instances running 6 nodes, so that's your 8 partitions. So you can see already we've got 6 partitions being worked on at once and 2 completed. I don't know about you, but that still isn't good enough. I still need more horsepower. So now we're going to scale that slave. To do that, we're going to use the scale command. It's going to ask me for how many instances I want running. This isn't the number I want to increment or decrement. This is the total number I want running. So if I want 10 instances running, I say 10. If I have 10 running and I want 2, I say 2, and it'll shut off 8. So in this case, because I'm running on a VM with memory restrictions, I'm going to do 3 instances. So I'll have a total of 4 instances working on this. 3 threads each, 12 actual workers. I'll be the same size. Your network's being a lot nicer to me than the last place. Thank you. Last one, this was going slow. And now you can see all the partitions are either completed or being worked on. 1, 2, 3, all the way down. So now what happens if I shut down some slaves? So let's shut down 2 instances. So I go down to 1 instance of the slave. So I should have 6 partitions being worked on. So now you'll notice, like this partition 3, he's not moving anymore. He's kind of frozen. Oh, actually, no, he is. Partition 4 isn't moving anymore, though. So this guy's frozen, but you can see some of these other partitions are still moving. If we wanted to be patient, we could actually see it pick up the rest of the work just as is. The messages have been put back on the queue, ready for somebody else to pick up. I don't know about you. I want to drink downstairs. I'm sure everybody else does. So we're going to scale these guys back up. Cool. Now you can see they're all working again. There's that 74 going up, 83. This should take just another minute. Anybody have any questions about anything I've covered up to now? Guys taking it easy on me tonight.
How about so we got the cloud, we got this.
Hmm?
Where do you draw the line, or is it even in the scope of this to talk about making a decision about what job goes to what machine, and to figure out machines or instances that are slower or bigger, and create more jobs as you need more stuff. So to automate some of this, and also to try and match what you're going to spread out to what you have available.
Unfortunately, Spring Batch doesn't handle any of those types of things. You'll notice, although I've configured it to have 3 workers, I created the partition a lot smaller. The reason I did that is I'd rather have more work available. So if I have a fast node and a slow node, the slow node picks up a partition, it's churning through it slower. If I got a faster node, he'll just keep pulling work faster. So it kind of is self-load balancing, if you will. That's without getting into true load balancers and more infrastructure components. That's really the easiest way to handle it.
I mean, it's fair to say that some of this is really not the Spring's responsibility. Spring Batch, it's the platform.
Exactly. Exactly.
But somewhere you have to figure out what the separation of concerns is.
Now, within Cloud Foundry, now it doesn't handle things like which box is slower than the other, but it will manage capacity. Where I've got this box, it's not going to send all of the. If I deploy 100 apps, it's not going to start. It's not going to beat up one box. In fact, it's essentially 2 components. It's a router and then the piece on each box. The router is responsible for managing what the loads are for each one of those boxes. That's like you said. That's really a function of your infrastructure. In this case, it'd be Cloud Foundry. You notice the job finished, so let's take a look at what it did. Ooh, I've got a new port open. Oh, it's 22. So to access the file system, we use VMC files. If you remember, I mentioned with partitioning, the data is, actually that is irrelevant for this because step 3 generated the report, so it's where the part application is deployed. So files part, and then the path where the file was put. In this case, it's tomcat logs sr.xml. So it'll pipe that out for me, and then give me a sec to copy that so we can actually read it. But you can see I've got nice XML with no writing of any XML parsers or any of that crazy stuff. So here's the output of my job. So you can see, I've got port 21 open. It's an FTP port. You can even see how many people are connected to it. It's kind of scary when you think about it. You can see that this is obviously a HostGator box. It's kind of interesting, the stuff you can see just by doing something simple like this. I think there's OpenSSH towards the bottom. Yeah, so they have OpenSSH, but it's on an obfuscated port. Instead of 22, it's 2222. Questions about that code or anything that we've covered up to now?
So is the expectation that you would have workers that could run multiple jobs?
Yes.
Is there any mechanism to prioritize one job over another? Then so you have two jobs that would kick off simultaneously, but this is more important.
For kicking them off, or like prioritizing the slaves?
Prioritizing the slaves, so that slaves would go to pick up these tasks.
While there is nothing in the framework to do that, you definitely could use queue priorities, so prioritizing messages. You'd have to wrap our message partition handler, but that would be the easiest way to handle something like that. For the record, the question was how to get the slaves working on stuff by priority. Any other questions on anything we've talked about tonight? Yeah.
So for Cloud Foundry, do you have control of the hardware if you want to?
You bet. You can deploy this on your own hardware in your own data center if you'd like. In fact, that's really one of the nice things about Cloud Foundry, from my opinion, is think about it from the ops perspective. We ask for a new server. Great. That means they've got to do more work. That means they've got to probably give us credentials that they really don't want to give us. That means they need to set up, poke holes in firewalls and all that type of stuff, right? Cloud Foundry, they get to keep all that information to themselves, and we get the pieces we need, which is we want to deploy an application. I don't care about the rest. Other questions? Cool. Let's look a little bit into the future of Spring Batch now that everybody's screwed up these slides. Spring Batch 2.0, or 2.2.0. So these features, actually, I'm lying on my slide. These aren't available in the current snapshot. Well, technically they are. But they're actually available in 2.0 release candidate 1, which came out this past week. Spring data support. So all the stuff I talked about, Neo4j, writing to Gemfire, MongoDB, reading and writing to the Spring Data repository abstraction, all that is available out of the box. Java config, the ability to build jobs via Java classes as opposed to all that XML we just looked at, is all available. Non-identifying parameters. This is a feature where right now, to take a step back, within Spring Batch there's the concept of a job instance and a job execution. If you think about a nightly job running once a night, so I've got a January 1st run, I've got a January 2nd run, I've got a January 3rd run. If that run fails and I rerun it, it's still the January 1st run. It just, I'm trying it for a second time. The January 1st concept is the job instance, and the job execution is each attempt at running those. Up to now, whatever parameters you pass in to a job, identify the instance. So if you wanted to run the same job, if you wanted to create the same job instance with the same parameters, the framework wouldn't allow you to do that. We had some hacks to get around that, but the framework wouldn't let you do that. Now we allow non-identifying parameters. So we allow you to optionally specify this parameter. Don't let it contribute to the identity of the job. We have Hibernate 4 support. We've had Hibernate support up to now. We've recently upgraded it to Hibernate 4, as well as a number of other enhancements and bug fixes. Spring Batch 3.0 is going to be the next release. In it, we intend to implement JSR 352. So the Java Batch spec, if you read it, it's heavily modeled after Spring Batch. So we are going to implement it. We're going to add and enhance our big data support. If you're familiar with the Spring Hadoop project, that's based on Spring Batch. It's really just a bunch of tasklets and readers and writers that are geared for Hadoop. We're going to take that and extend it even further. We already have clients that are using Spring Batch and Spring Data as a replacement for Oozie, if you're familiar with Hadoop. We're going to take it even further and work on essentially replacing Oozie, Scoop, and Flume. We want to lower the barrier to entry. Obviously, we saw a lot of XML tonight. We want to make that easier. We want to make our build process easier. We are talking about expanding the namespace support. We're talking about potential DSL options. One thing I should mention here, everything on this slide is subject to change, so don't hold me to anything I'm saying right now. Obviously, we also looked at that big XML file that with all the Spring integration stuff. We want to simplify that as well. We want to make that easier to use. Some useful URLs. The top one's the Spring Batch homepage. Then you've got the Spring Batch forum. I'm in there. I try to be in there once a week at least, if not more. But the community is big and busy, so there's lots of stuff going on. So if it's not timely, I'll definitely get to it. Otherwise, the community is like I said, it's busy. Spring Batch on GitHub. I can't emphasize enough, first of all, checking out the code, but also contributing to open source projects. I can't think of a better way of growing your career than contributing back to open source projects. Think about how many times you've been on a job interview and they say, tell me about this project or tell me about that project. And you can only give a little bit of a description, and you can't show them the website because it's behind some firewall or password protected site. And God knows you can't show any of the code because of your non-disclosure agreements. Contributing back to open source projects gives you the ability to point, I wrote that code. And not only did I write it, but millions of developers are using it every day. The last thing on here is my personal GitHub account. This talk, including the source code, the PowerPoint, and directions to run the example are there, as well as my fork of Spring Batch and any other things I'm playing with at the time. Thank you.